All right. This is for Jack and Jace and who else? That's it. Just Jack and Jace. All right, here we go. For 3, we have the probability of at least 1. I'm going to talk about this for like the next 15 minutes. This is a huge concept, and it's a little bit hard to understand. All right, are you buckled up? Are you ready? At least 1. Okay, at least 1. Finding the probability of at least 1. All right, here we go. I'm going to do an example, and let's say I have 2 children. Let's say 2 kids. And then I'm going to do the same thing with 3 kids. Okay? Got it? 2 kids, 3 kids, whatever, right? If I have 2 kids, I could have a boy, a boy, girl, a girl, boy, or a girl, girl, right? Got it? If I have 3 kids, I have boy, boy, boy. Do you know how many combinations are there on 3 kids? 8. How do we know that it's 8, by the way? 2 times 2 times 2, because boy, girl, boy, girl, boy, girl, right? 3 of them. 2 times 2, that would be 4 options here. That would be 8 options here. Heaven forbid. Actually, I do have 4 kids. If I have 4 kids, we won't list all these out, but how many options do I have for 4 kids? 16. It would be like 2 times 2 times 2 times 2, which is 16. 16 combinations, right? Okay, 8 combinations, 4 combinations. All right, let's list out all the ones for 3s. So we got boy, 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 girl, boy, girl, boy, boy, girl, girl. That's 4 of them. Okay, now let's start with the girl side. So girl, boy, boy, girl, boy, girl, 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 boy, and girl, girl, girl. That is all 8 combinations. Yeah. I am not going to list out the ones for 4 kids because that's 16 long, right? Okay, all right, if I'm doing, I want to know the probability that I get at least 1 boy if I have this happening. I want to know the probability of me getting at least 1 boy. At least 1 boy, all right? Does this one give me at least 1 boy? Yes. Does this one give me at least 1 boy? Yes. Does this one give me at least 1 boy? Does this one give me at least 1 boy? No. So what's the probability of me getting at least 1 boy? 3 over 4, right? I have a 75% chance of getting at least 1 boy. Got it? Now let's do the same thing here. Let's do the probability of at least 1 boy here, right? At least 1 boy, 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 at least 1 boy? No, right? So what are my chances of getting at least 1 boy in that list? 7 out of 8. All right, now when we do this, instead of doing the probability of at least 1, I'm going to do the equals 100% minus the probability of none, right? Does this make sense? Okay. The probability of me getting no boys was 1 out of 4 here, and 100% minus 1 out of 4 is 3/4. You see that? Okay. There is only 1 combination in this list that will not give me at least 1 boy. 1/8. If I take that and subtract that from 100%, that would be 7/8, right? There is only 1 combination out of 4 kids that will not give me at least 1 boy. What is that combination? Girl, 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 girl. And that is 1 out of 16 combinations. So how many will give me at least 1 boy? 15 out of 16 combinations will give me at least 1 boy. Does that make sense? Okay. So when you're doing at least 1, it's better to look at what's the probability of no boys happening, find that probability, and then subtract it from 100%. Does that make sense? Okay. Good. All right. Okay. Now, let's do another one over here where I'll make it a little bit harder. Ready? Okay. The probability of me killing a tree or a plant, let's say a plant. Okay, the probability of me killing a plant is 0.9. I have a 90% kill rate for plants. That's being generous. Okay. I have a very high kill rate for plants, okay? I just don't have the time or I forget about them and I don't water them and then they die, okay? So my kill rate for plants is 0.9, okay? If I have 5 plants. Find the probability that at least one lives. Okay, find the probability that at least one of them is going to live. Okay? All right? 5 plants, at least one of them lives. Okay? Now, if I'm talking about all 5 of my plants, I could have a live, which is probably not going to happen. I could have a live, die, right? I could have a live, die. Or I could have a live, die, live. Do you see how long this list is going to be? Right? My 4th one could die, my 5th one could die, whatever. Do you know how long this list is? How many elements are in that list? 2 times 2 times 2 times 2 times 2. 5 of them, right? 2 to the 5th power is 32. If I wanted to fill this list all the way through, it would be 32 units long, right? Okay? And all of those combinations except for one is going to give me at least one of them living, right? The only one where at least one of them doesn't live is if I do die, right? So one combination out of 32 is going to be them all dying. So the chances that at least one lives is 31 out of 32, except for, that is if my kill rate is 50%, and my kill rate is not 50%. So how do I do that? So, yes, there are 32 combinations, okay? But what I'm going to do is I just told you that the probability of at least one living is equal to 100%. You maybe want to write this down. Minus the probability that all die. Right? All die is the opposite of at least one living. Correct? At least one living, all dying. I want to know 100% minus the probability that all die. Okay, so we've got to figure out what the probability of all of them dying. What's the probability that I get die? Nope, because I have a 90% kill rate. So it's going to be higher than 1 over 32. Die would be die times die times die times die. What's the probability that it dies? 0.9 times 0.9 times 0.9 times 0.9 times 0.9. What's the probability that, or you could say 0.9 to the 5th power. What's the probability of all of them dying? 59%. Okay? So, the chances of me killing all of these plants is 59%. That's the majority of the time. That makes sense to me. Right? 59%, that checks out.
So where did the 31 out of 32 come in?
Okay? 31 out of 32 is if we're dealing with a 50-50 shot like we're doing with boys and girls, or like that, right? And I'll show you how that works out. If it's 50-50 and I'm doing die, right? This would be 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which would end up being 1 over 32 is my chances of dying. Does that make sense? Yeah. Okay? But my chances of dying are not 1/2. Okay? We're not doing this procedure like we did over there. Okay? It's 0.9. So I'm taking 0.9 to the 5th power. So my chances that all of them die are 59%. What's the chances that at least one lives? At least one lives.
Would you do 59 minus? No.
100% minus 59%. The chances that at least one lives. All of these combinations are at least one living. The only combinations where at least one doesn't live is if they all die. And the chances of them all dying is 59%. So I have a 41% chance that at least one of them will live. Does that make sense? Okay? So, rather than doing the probability that at least one of them lives, we're going to do the probability of none subtracted from 100%. 1 minus the probability of none. That's the huge thing there, right? Every other combination is going to have at least one, except for the one where there's none, right? Okay, we'll see this here in a second. All right, here we go. So right here, probability 1 minus the probability of no occurrences of the event. That's what we're going to do each time. All right, here we go. A study by Square Trade found that 60% of damaged iPads were damaged by backpacks.
Just 6.
Okay, not 60, 6% of damaged iPads were damaged by backpacks. The other 94% were damaged by other ways. What's another way of damaging an iPad?
Throwing it off.
Dropping it, throwing it, slamming your pencil in there. Have we done that before? Yeah, like your pencil's stuck inside your iPad and you, oh no, I'm thinking of Chromebook. iPads you don't slam, right? Okay, whatever. But anyways,
Overusing it for math.
I struck my son, maybe I shouldn't say this, I struck him gently over the head with an iPad the other day. I went, boop, what are you
Not
doing?
gentle.
That wasn't gentle.
Okay, it might have been a little harder than that, actually.
Tell me.
Okay, but I could very well have broken his head or the iPad, right? Okay, so that's another way of breaking an iPad. But 6% of them.
Recording.
This is, oh, I am
It's going
recording.
on YouTube.
Oh, shoot. Self-incrimination. All right. 6% are damaged by backpacks, okay? If 20 backpacks or 20 damaged iPads are randomly selected from the probability that at least one was damaged by a backpack, okay? So,
0.6 times 20.
No.
0.06 times 20.
okay, I want to do the probability of at least one, right? Means that I'm going to do 100% minus the probability that it was not by a backpack.
So 94.
Not backpack. Okay? Yeah, it was not damaged by a backpack. Okay, what's the probability that all 20 of them are not damaged by a backpack? What's the chances that the first one's not damaged by a backpack?
Don't you just do 20 times 0.06?
94%, right? 94% is not damaged by a backpack, though. We want the probability of not backpack. So I got to do 94%, right? Okay, so 0.94, 0.94, 0.94, 94% to the
How did you know how many
20?
times?
I was going to say.
20th power. You keep going.
Oh.
There's just 20, there's 20 of them,
Okay.
right?
9%.
So I'm going to take that to the 20th power, right? The chances that it's not damaged by a backpack would be 0.94 times 0.94 times 0.94 times 0.94, 20 times, right? Or 0.94 to the 20th power. That is what percent?
Oh well,
It's
the
29.
percent is 29%.
29%. If I take that 0.94 to the 20th power. So what's the chances that it was at least one of them was damaged by a backpack?
So 100 minus.
71%. 100% minus the 29%. Does this make sense?
Yeah.
Kind of. The weird part is, do I use the 6% or do I not use the 6%? Okay, that's why I have to write my thoughts out. I have to say probability of at least one means the probability of none damaged by a backpack, right? Well, if it's not damaged by a backpack, that means it's 94%, right? 94% are not damaged by a backpack. So I've got to go with the 94% and not the 6%. Okay? Make sense, kind-of-ish?
So the 71 is the probability of at least one iPad being damaged.
Yes, 71%.
Out of those 20.
This is the probability, yes, I'm going to write that out because that's useful information. Probability that at least one of the 20 is damaged from backpack.
Because the concept of this makes sense, but sometimes the wording is.
Yes. Yep, I get that. Okay. Good. They need to do, I wish I had more. Can I do another one? Let's do a homework problem.
Can you? Yeah. Let's do that. Can we be done with examples for today?
I want to do one more. I want to do this contingency table.
Okay.
Okay, I want to do example 2, but we'll do a homework problem really quick first. Let's go to.
7?
I want to do number 5 is easier than number 7 because that's a 50-50. But number 7, births in the United States. Okay, the true probability of a baby being born a boy, probability of boy, I'm just going to write this down, is 0.512. So it is a little bit higher than 50-50. Okay, among the next 6 randomly selected births, what is the probability that at least one girl? What's the probability of at least one girl? Okay, at least one girl. So I'm going to do the opposite of that. I'm going to do 100% minus the probability of what's the opposite of at least one girl? No. What's the opposite of getting at least one girl? No girls, right? Or all boys, right? The probability of no girls. Okay, I'm going to do the probability of no girls.
Which is the
Okay,
point
and there's
five.
6 of them. 1, 2, 3, 4, 5, 6. What's the probability that this first one is not a girl? Yeah, because that would be boy, right? 0.512. Probability this one's not a girl, 0.512, 0.512. So I take 0.512, blah, blah, blah. I take that to the 6th power, right?
1.8% chance.
Okay, that's a 1.8% chance. 1.8%. Okay, so what's the probability of getting at least one girl? 100% minus 1.8%, 98.2%. Does that make sense? Okay, so you're going to do this every single time. The probability of at least one girl is 100% times the probability of no girls. No girls is the opposite of at least one girl, right? No girls is the opposite of at least one girl, okay? So I do the probability of no girls, 0.512. Do we see why it's to the 6th power? Because we're talking 6 girls, right? My chances, if I have 6 children, of getting at least one girl is a 98.2%. Now, you've seen the families that have 6 boys or 6 girls, right? Like, you're close, right? You have 5, okay? You're in the very, very, very small percentage that has none of that. Like, none of the opposite gender. And there's twins, yeah, yeah. Crazy.
You have 5 girls and twins.
And twins that are girls.
I was thinking about this the other day, is that I'm as genetically similar to Avery as Avery is to Lauren.
Yeah, because they're not even identical. Yeah, that's absolutely true. When I was in high school, there was twins that were 2 grades ahead of me that looked identical to me. Like, they were very, very, very identical looking, but they were not identical twins. They were fraternal twins. So they explained it to me like if they were born like a year apart, they would look exactly the same at those respective ages. Like, they would just be that. Like, you've seen the siblings that are like, holy moly, you guys are really like twins, basically. That's what these girls were, but they were twins, but they were fraternal twins. They just looked identical. It was crazy. It was the weirdest thing.
I wonder what were the chances of getting all girls and having twins?
I don't
out of
know.
5 girls.
I don't know. Yeah.
That'd be an
Now,
interesting
question.
statistic.
And you probably don't know this information, but I have and I don't know if this is how the body works, but I have a friend who had like 2 miscarriages, and it's the same friend that's in Florida right now. She had 2 miscarriages in the middle of her like 2nd and 3rd boy. Okay, so she has 3 boys, right? And she had 2 miscarriages, and she sent those miscarriages in because she had to have a D&C. She was like decently far along when this happened, and she sent the baby in for genetic testing to basically see why she had a miscarriage that late. And they found out that both of those babies were girls. So it was basically, and I don't know if this is how this works, but basically as though her body like would not carry a girl. Does that make sense? What?
It killed the girls.
I mean, like, there could have been something else wrong, but like their body wasn't set up to carry girls. I also have another person that I know that she conceived twins, and then like 2 years later she had twins again. So she has 2 sets of twins, and the doctors thought that like, and she did have miscarriages in between there, right? So she miscarried, and those were like single cell, like 1 baby, right? So it was of the doctor's guess maybe that her body did not want to support just 1 baby. Like, it like rejected if there was only 1 baby in there. It would only support like higher amounts of hormones from the 2 babies. Otherwise, her like body would just slough it off. Does that make sense?
Weird.
So like her body was only like genetically engineered to produce doubles.
So whether or not twins
Yeah.
are genetic, because aren't twins sometimes genetic? Like,
I
I don't know.
no, fraternal twins are genetic,
Yeah. So my
but identical twins are not.
my grandpa.
Identical twins are just an
I only
anomaly.
know of fraternal twins in my family.
Oh, really? Yeah, yeah.
My grandpa was a twin. I
Yeah.
have cousins that were twins, and then like great uncles.
So fraternal twins,
On both sides of the family.
yeah.
So I guess
So-
it's probably bound to happen.
Fraternal twins are genetic because, and it has to do with the woman releases too many eggs at once, and both of them get fertilized, and like her body like takes them both. Basically, is what happens. So it has to do with like like your side, like your mom, and probably pass that gene down to you. So you could potentially have fraternal twins at some point, because, you
So
know,
identical is when it splits.
identical is just an anomaly where it just splits weird and nobody knows why it happens, whatever. But fraternal is like genetic, like you might carry the gene that makes you dump a whole bunch of eggs at once, you know, like,
Twins, Megan.
I feel like twins would be kind of fun.
so,
I
anyway.
like triplets.
My,
The twins and Casey.
so one of my other really good friends has spontaneous triplets, right? Like she had no
Triplets and
fertility, whatever. She has a set of identical twins and then like a third fraternal triplet, right? So like it was 2 eggs to begin with, and then the 1 egg split, right? So that was weird. The fraternal part is genetic, and actually what's super crazy about this story is that she actually had a miscarriage of fraternal twins earlier, like when she first got married. They were pregnant and she had a miscarriage at like 9 weeks or whatever, so she had to go in and have a D&C and all the things. Right?
Miscarriage is like really common, like 1 in 3 people. Isn't it?
1 in 5, I think.
1 in 5.
Yeah. So it's a lot more common than you think, and people are talking about it more than they used to. They used to be like hush hush, like let's not speak about this, and now they're like trying to help women's mental health dealing with that, and so they're more vocal about it.
Like crazy so random.
No,
but then
no,
wait.
it happens quite a bit.
Yeah.
Yeah, it happens quite a bit. So
Chloe telling you Lily Chandler had both.
Yeah, she has both parts.
yeah,
She was-
Yeah.
Yeah.
So then
on a different topic.
just get one. or the
She
other
said that she
removed.
was a lesbian.
So yeah, she went her whole
So
life
was she
and
really a she?
She was.
I don't know. Sometimes
She had both
so
parts.
like they're called hermaphrodites is what they're called. They have both boy and girl parts. I don't know. I heard this at one point and it makes sense to me, but I don't know if this is how it works. But sometimes like if you have a twin and it dies, you like absorb the twin.
I don't
Did you know that?
Like she has.
You absorbed your twin in the womb? Ha! You absorbed your twin. Okay, so sometimes, and I heard this and I'm like, I don't know if that checks out, but anyway, I heard this once. So like potentially like she could have had a male twin, and when she absorbed her twin, like she absorbed some of its DNA, and then it ended up being that she had both parts. I don't know if that's true or not. I don't know if that's how it works. I'm not a scientist. I don't know how that works. But anyway,
It's like
but yes.
your internal parts are one thing and your external parts are the other. So it's not like you have like.
But like, would it like?
So she had like a male appendage and she had a uterus at the same
Yes.
time.
Yeah.
Yeah.
Or
Is
you can have the
basically what-
opposite. You
yeah.
can have like a prostate, but then have like.
Yeah.
Yeah.
Yeah. So anyway,
No,
that's
it's
how
so
it works.
Weird, and then yeah, you can actually.
Sometimes those people will end up like,
Recording, by the way.
yeah, we are recording. Yeah, they're getting an education.
Yeah,
It's
this
fine.
is-
It's fine.
this
I'm
is on
not.
Kids
whatever.
YouTube, by the way.
Oh, whatever.
She flagged
Um,
her case.
No one
So anyway.
watches this.
Yeah. What's up? Yeah. Okay. Let's go through example 2.
People having both parts.
Woo!
Wanna join?
It is so interesting though because some of them have surgery, some of them just do hormones, some of them don't do anything.
Great. Yeah, it's crazy. Okay. So, let's talk about this contingency table. I'm sorry that it's on like 2 different pages. Sorry. But we have, I think we've seen this table before. Positive, negative results, drugs and no drugs in your system, that type of thing. We've got 70 here that test positive. We've got 485 that test positive. I'm going to do my totals. This is 50 people that use drugs, 505 that don't use drugs. So we tested 555 people total. Yeah? Okay, now, here we go. If one, I'm going up to part A, so sorry that these are not on the same page. I apologize. They're like, you're going to have to flip back and forth. Sorry. I'll keep my table up here if you don't want to have to flip, okay? If one of, and this is a conditional probability, okay, under a certain condition, okay. If one of the 55 test subjects is randomly selected, find the probability that the subject had a positive test given, circle the word given, that the subject uses drugs. Okay, so I want to find the probability that they test positive, and the given, they write as like a little line right here. So given uses. Okay, that's what we're doing. We're finding the test, the result, the probability that it's a positive given that they use drugs. Yeah? Okay, now, when we're doing this, It is a conditional probability, so we are no longer looking at all 555 subjects. I'm only interested in looking at the people who do what?
Use drugs.
Use drugs. This is my new bottom number, right? I only want to look at the people who use drugs. So how many people actually use drugs? 50. 50 is my new bottom number. Of those 50, how many tested positive? 45. So 45 out of 50, or 9/10 is going to be my new conditional probability, right? That word given tells you what your new bottom number is. All right, part B. If one of the 555 test subjects is randomly selected, find the probability that the subject uses drugs given that they had a positive result. So now they flipped it around and they say use drugs given that they tested positive. Okay, so it's kind of the opposite, but is it going to end up being the flip of that? Is it like 1/10? No. Now my new bottom number is not 555 anymore. It's only the people who are positive user, or positive for drugs. So 70 is my new bottom number, and of those 70, how many people use? 45. 45 over 70 is like 9/14, or whatever you want to put. What is it?
64%.
0.64? Sure. Either one of those. So whatever's after the word given will tell you what your new bottom number is, right? Yeah? Okay. Let's do this. I want to find, how many blue-eyed people do we have in here? Let's just do boys. Okay, so in here we have 1, 2, 3, 4, 5, 6, 7, 8. There's 8 of you, right? So 8 people in here in this room. Okay, right now. 8 people in this room. Okay, we'll go 9. Hallie went to the bathroom. Okay, 9 people in there. I want to find the probability that I have a blue-eyed person given that they are a boy. So now I'm not looking at all of the 9 people in this room. I am only looking at the boys. How many boys are there? 3 in this room. How many of you have blue eyes?
All of them.
Do you all 3 have blue eyes? Do you have blue eyes?
Mine go either green or blue. I don't know.
Okay, we'll say you don't have blue eyes then, so it makes it interesting. So 2 out of 3. Okay? We're not looking at all 9 people anymore. We're only interested in talking about the boys that have blue eyes, yeah? Okay, do you see how that bottom number is affected? Yes. Okay, so the given part, that will tell you what your new bottom number is. Yeah, it's kind of like a fraction bar, absolutely. Yep, okay, good?
That's good.
All right, there you go. That's good.
What
We'll stop.
question?
You should be able to do number 3, I think. Okay, because that has the given in there, right? Number 5, you should be able to do. Number 7 is already done. Number 9, you can try. This is a tricky one.
It says with replacement. Do we have to try it?
Number 10. Oh, with replacement just means that, like, you can have a phone number that has, like, 11111. And you can, like, whatever. Okay, and then do 15. Actually, you should be able to do. Well, no, it's fine. You should be able to do 15 and 13. I don't know why those are in a different order.
Number 5.
So the whole first page, and then 15, 13.
But I pretend it depends on what color your pee is.
Yes.
I know how
Yes.
Let me go look at the blood drives.
Okay. All right, whole first page, 15, 13. Go.